This question states, for an element with sigma x equal to 100 megapascals, sigma y equal to 100 megapascals, tau xy equal to 100 megapascals, and the other stress is equal to 0, use the invariance of the eigenvalue problem to find the maximum principal stress, sigma 1. So if we go back to the notes and what we discussed in class, we see that there is a method, or maybe a couple of methods, to find the principal stresses in 3D. And this invariance, the eigenvalue problem, can be thought of instead of finding the roots of sigma cubed minus I1 sigma squared plus I2 sigma minus I3 equals 0 as using matrix manipulation to find the solution. And so we'll show you in code how to do this. It's not imperative that we understand all the linear algebra at this point. It's just showing how, or right now we're just showing how we can go about solving for the principal stresses, essentially using these equations and showing how we can implement them in code. So let's go ahead and go back to the problem at hand and use the code that's provided in the class. So we'll go to the website and then come down to the mechanics and materials section, and we are in the session 20 about absolute maximum shear stress, and we'll go down until we find the material for Colab. And so here is the script that we're pulling up for calculating absolute maximum shear stress. And for this situation, so I hit Control Enter to go ahead and play the first cell, we're going to use a library that gives us the tools, or some tools, associated with linear algebra. Okay? And of course, we use NumPy as well. So we've already shown how we can use essentially two methods for example 20.1. All right, this is using the solution to the eigenvalue problem, as you see here. Or we can solve for the roots, all right, of that third order polynomial by putting in the coefficients for that third order polynomial and then using a root solver and NumPy. So we're going to go ahead and do the same thing, but just enter the values that we've been given. And in this case, we said that sigma x is equal to 100 megapascals, sigma y is equal to 100 megapascals, and tau xy is equal to 100 megapascals. So we'll simply put those values in. So 100, 100, 100, and now this goes to 0. So we hit Control Enter, and we see that it's solving through both methods, and the principal stresses will end up being 100, 100, 100, okay, through the eigenvalue solution, or they'll be pretty much 100, 100, 100 through the root solver that we have here. Okay, I hope you find this example or this video on how to approach this problem helpful. Thank you.